In this video, we will use these formulas to solve for missing probabilities. In the past, I have given you Venn diagrams and two-way tables, and we didn't really need the formulas then. But in this video, I'm going to give you word problems, and there won't be any visuals. There won't be any Venn diagrams to use, no two-way tables, so we will have to use these three formulas. Notice that the first formula is the only one that involves given, probability of A given B. So if the word given turns up, I'm going to use this formula. This third formula, the addition rule, is the only formula that involves OR. So if I see A or B, I know it's going to be this formula. And if I don't see either one of those two things, it's probably going to be the middle formula. So let's take a look at problem number one. The probability of a randomly chosen boy playing basketball is 0.3. So there's one event right there, is playing basketball. So let me go ahead and define that event right now. Okay, so I will call event B playing basketball. The probability that a boy plays basketball or football is 0.4. Okay, basketball or football. I can already see what the other event is going to be. We already have basketball, but now they're mentioning football. So that's going to be another event. So F equals playing football. The chance that a boy plays football is 0.25. Find the probability that a boy plays both basketball and football. Okay, let's start by listing out the probabilities we know. Probability of playing basketball is 0.3. So we know that the probability of B is 0.3. The probability of playing basketball or football is 0.4. So the probability of basketball or football is 0.4. Okay, the probability of playing football is 0.25. So the probability of F is 0.25. Now, this green probability is the one we want, the probability of basketball and football. So we're looking for the probability of B and F. Now, I'm noticing that this problem does involve OR. All right, I'm seeing the word OR right here. And this third formula is the only formula that involves the word OR. So we're definitely going to have to use this formula. So the probability of A or B is equal to the probability of A plus the probability of B minus the overlap. So I'm going to say that same thing again using B's and F's. So the formula says the probability of B or F should equal the probability of B plus the probability of F minus the overlap. So minus the probability of B and F. So let's substitute in everything we know. I know the probability of B, so that's 0.30. I know the probability of B or F. That's right here. So that's why I will put 0.4 in the front. I know the probability of F, and that goes right here, so 0.25. What I don't know is the probability of B and F. So I'm going to subtract. I'm just going to leave this as the probability of B and F. Okay, so we just need to get this by itself. We need to solve the equation for B and F. Okay, we're going to get this by itself. So our next move should be to go ahead and combine like terms. Let's put these together. So that's going to give us 0.4 is equal to 0.55 minus the probability of B and F. All right, that puts us one step closer. Hold on, my equal sign looks a little bit too much like a minus. Okay, so again, I still need to get this part by itself. So that's why now I'm going to subtract 0.55 from both sides. Okay, because of this minus sign over here, that's why I'm subtracting instead of dividing. Anyway, so 0.4 minus 0.55. That's negative 0.15. And that's equal to, see this negative sign? It's still there. Negative probability of B and F. So, I don't like the fact that these are negative. I need them both to be positive. So, I'm going to divide both sides by -1, and that will just have the effect of turning them both positive. And that's going to give me the final answer. So the probability of B and F is equal to 0.15, which is equal to 15%. Problem number 2. A sample was taken of a rare breed of cat. Their coats can be spotted, striped, or both. Researchers found that 32% of the sample had striped markings. Okay, so there is an event right there. 32% had striped markings. 41% was spotted or striped. Interesting. I see the word or again. Okay, 7% were spotted and striped. What is the probability that a cat's coat had spots? Okay. The red and the green, these are sort of combination statements mentioning the red one is spotted or striped, the green one is spotted and striped, but the yellow and the blue really show what the two events are. So looking at the yellow, one event is having striped markings, and the other event is having spots. So I have to think what letter I'm going to use, since striped and spots both start with S. So I think I'm just going to switch it up and do, I guess, X and Y. I think I'll just do X and Y. That was bothering me. I changed my mind. I'll just use two letters. So I'm going to let ST equal the percentage of striped cats. So ST will equal striped. And SP will equal spotted. Okay, so 32% is striped. So that means that the probability of striped is 0.32. All right, 41% is spotted or striped. So the probability of spotted or striped is equal to 41%, 0.41. 7% spotted and striped. So the probability of spotted and striped is 7%. Whoops, I should have said 0.07. 7% is 0.07. What is the probability that a cat's coat had spots? So what is the probability of simply spots? That's what we're trying to find out. Okay. Again, as soon as I see that the problem involves or, all right, spotted or striped, that tells me to use this third equation. So I'm just going to write this using spotted and striped instead of A and B. Okay, so the probability of striped or spotted is going to equal the probability of striped plus the probability of spotted minus the probability of striped and spotted. Okay, let's substitute in everything we know. 32% had stripes. Okay, so that means probability. So we know the probability of stripe. That's 32%. So 0.32. Okay, let's see. Spotted or striped. We know this. So this is 0.41. All right, spotted and striped. Okay, that's this way over here, but we know that. So that's going to be 0.07. The only thing we don't know is spotted. We don't know the probability of spotted. Okay, so what am I going to do? Look, guys, these are like terms. This and this. They're on the same side of the equation. They are like terms. We need to combine them. So just looking at a calculator, we're talking about what is 0.32 minus 0.07. That's 0.25. So I just combine those like terms, and I get 0.25. So that means 0.41 is equal to probability of spotted plus 0.25. Okay, that's the combo of the two ones I just highlighted. So to get the probability of spotted by itself, I need to subtract 0.25 from both sides. And this should give me the probability of spotted, which I want. So that's 0.16. And that could also be written as 16%. Problem number 3. having blonde hair and being a freshman are independent events. So sounds like we have our two events right there. Having blonde hair is one event, and being a freshman is another event. So let's just go ahead and write that down. We will let the letter B represent having blonde hair. And we will let the letter F represent being a freshman. Now, what else you got? If a student is randomly selected, the probability that he or she is a freshman is 30%. Okay? Probability that he or she is a freshman is 30%. The probability that he or she is a blonde freshman, okay, that's both of them at the same time, is 12%. All right, so the probability that he or she is a blonde freshman, that's the same thing as saying blonde and freshman. What is the probability that a randomly selected student is blonde? Okay, so let's record the probabilities that we know. The probability of being a freshman is 30%. So we know that the probability of F is 0.30. The probability of being blonde and a freshman is 12%. So the probability of being blonde and a freshman is 12%. So that's 0.12. What is the probability of being blonde? So we're being asked to find the probability of B. Okay, so next we need to decide which formula we're going to use, which of these three formulas. The problem did not say anything about given, and none of the expressions were or expressions. Okay, we have the individual expressions shown in blue and yellow. The one combination expression said the probability that he or she is a blonde freshman. That's not blonde or a freshman. A blonde freshman is blonde and freshman. Okay, so there are no or statements. So probably this is going to be the middle equation. It did not mention given, didn't have or in it. That leaves the middle one. Okay, it even mentioned that the events were independent events. All right, in the directions. It said, hey, look guys, these are independent events. That's another clue that it'll be the middle equation. So the probability of A and B is the probability of A times the probability of B. So let's translate that into blonde and freshman. So the probability of being blonde and being a freshman should equal the probability of being blonde times the probability of being a freshman. So let's see. What do we have? I know the probability of being a freshman is 0.30. So I'm going to go ahead and say times 0.30. I know the probability of being blonde and freshman. That's 0.12. So that goes here. What I'm looking for is the probability of being blonde. So I'm just going to leave that here. So the way you solve for the probability of being blonde is to divide both sides by what's right here next to it. I'm going to divide both sides by 0.30. That way these cancel each other out, and that's going to simply leave the probability of being blonde all by itself. Now I just need to go ahead and divide this so I can see what decimal it makes. All right, that comes out to be 0.4. So that's it. That is the probability of being blonde, which is also the same thing as 40%. Okay, so that's another valid way to write it. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.